In my previous video, I have demonstrated the AlwaysON setup using two instances, one being a virtual instance. Let me draw the in my previous video I have set up AlwaysON between two servers, and this is cluster and this is standalone. We had two node cluster. This is node 1 and this is node 2. We did the cluster SQL cluster and we have given the name VSQL, and we set up the AlwaysON between VSQL and node 3. This is what we have done in the previous video. Now in this video what I am going to do, I will set up AlwaysON between three servers. All three servers are standalone. Since we had the cluster, we couldn't simulate the automatic failover, because if AlwaysON has a cluster replica, you cannot set up automatic failover. But if you have standalone servers, you can set up the automatic failover between any server to any server. But you can do the synchronous data transfer between the cluster server and the standalone server, but you cannot do the automatic failover because cluster itself has a automatic failover. On top of that, you are using one more resource group to do the automatic failover, which is not permitted. So that's why you cannot do automatic failover. So now in this setup, this is scenario 2 that we initially discussed. This is scenario 1 and this is scenario 2. Alright, let's start working on this scenario. We already have, this is the domain controller server, and we have three servers, node 1, node 2, node 3. I have installed SQL Server 2012 Service Pack 1 on three servers. And all three are standalone servers. Now the first step in the AlwaysON setup is we need to cluster the replicas. We need to identify the replicas and we need to cluster them. Let's explain a little bit before we go. This is the primary replica, and this is the failover replica in the primary data center, let us say, and this is the reporting server. Your reporting users or business intelligence developers might use this server for their queries, or for example you might want to run some queries and you can run against this server. Basically you wanted to use this server as a reporting server. Moreover, this is in the remote data center. Let us say you have two data centers, one being primary for live transactions, and you have remote data center. Since you have good connectivity, network connectivity between these two servers, because these two resides in the same primary data center, so you might want to set up a synchronous data replication between these two servers, and whereas you set up asynchronous replication between these two servers, because there might be network latency because this server is maybe 1000 miles away from your primary data center. A different subnet altogether, where you don't have high caliber server, or might not have enough resources to host the live database server. So you wanted to have this server node 3 as a reporting server for reporting purposes and set up asynchronous between node 1 and node 3. This is moreover, this could be used for disaster recovery purposes. In case if a primary data center goes down, you can do a forced failover between node 1 or node 2, whichever primary here. From this data center to this data center. Okay. Uh, in case of forced failover, uh, you need to these databases, whatever the databases on the primary data center, you will take the secondary role and will be in the suspended mode, because there might be some transactions in the send queue which might not have replicated to the secondary data center. Okay, so you have to manually go through the records and bring the databases up. Okay, so let's work on this scenario. Here I have three servers, node 1, node 2, node 3. First step I need to do is create a cluster and add these servers in the cluster. Okay, so I have installed standalone on three servers, and standalone instance is up and running. Now let's create a cluster. And we need to select the nodes that we wanted to add. So these three servers going to participate in the cluster. And this is our Windows cluster. I will say WinClus. I'm not going to add any storage because I'm not building a typical SQL cluster where we have the shareable storage between the nodes. This is not that setup. This is just to create a uh, three node basic cluster for always on availability groups. Always on availability groups depends on Windows cluster for some of the features like failover, health check between the servers, just to make sure other servers are up and running. And there are certain features that always on depends on Windows cluster. That is why you need to cluster. Okay, but this is not a old style cluster where you have to create the shareable storage and a lot of other things. Just very basic cluster. Whatever the nodes, whatever the replicas that is going to participate in the always on, those nodes you need to add to a cluster and create a IP address. What we are creating is Windows cluster. Alright, we created the cluster. Now let's take a look at the cluster details. And this is our cluster. There are no roles. When we create the availability group, then you will see the availability role here under the roles. Right now, no items found. And here in the nodes, you will see the nodes that we added, the servers or computers. Okay, storage, there is no storage. We didn't add any shareable storage. Networks, you will see that we have created two networks, one for public and one for private. So just to create a redundancy in network, in case we cannot have single point of failure here, so you need to create two network connections. Typically one is enough, but two is recommended. And here you will see the cluster events. If there is any events, informational warning or error messages regarding the cluster, you will see that here. Okay, look, here you have the cluster, basic cluster information. This is our client access point. This is how we connect to the cluster, Windows cluster. Typically, you may not be using WinClus, this cluster name, but sometimes you might want to ping the client access point, and this is the IP address that we have given. If anybody wanted to connect to this cluster, they can use either DNS name WinClus or the IP address here. Okay, now we are done with Windows cluster. um, if you take a look at this is the SQL Server configuration manager. Okay, so if you go to the properties under the always on availability group, you will see the cluster name. Whatever the cluster name we created, it will be listed here. If the server node 1 where we are doesn't participate in the cluster or does not belong to any of the cluster, then you won't be seeing anything here. Before we set up the always on, we need to make sure to enable the server is allowed to participate in the always on. So we have to check this option. So now this server node 1 always on is enabled. Let's do the same thing on the other two nodes. By the way, you need to restart the SQL Server. Okay, I have restarted all the servers. Now let's check okay, so if you verify whether this server has always on enabled, you can run this query. Okay, it says it is enabled. Okay, now let's create the okay, we need to refresh this node. Now let's create always on availability group. So I will create this is my availability group name AG1 because I am going to create one more group later. So in order to avoid confusion, so I name this as AG1 and this is my availability group name, and there are no databases to participate in the availability group. So we don't have any database. Let's create a couple of databases. Okay, so the database files will be created in C drive. Let's create one more database. Okay, so we created two blank databases. Now let's refresh. Now you can see these two databases are available to use in this availability group, but full backup is required. So we have to take full backup of the databases prior adding to availability group. Okay, so we took a backup of test1 and test2. Let's remove that backups. Okay, look, now we have taken the backup, so let's refresh. Now it says it meets the prerequisites. Alright, let's select the two databases that we wanted to add to the availability group. Now here you need to identify the replicas for this availability group. Now I am going to say all three servers, and this is my primary server and this is my secondary server. I wanted to have automatic failover between these two servers. Okay, in order to have automatic failover, I need to have a synchronous commit between these two replicas. Okay, and asynchronous replication between node 1 and node 3. So I'm not going to select the synchronous commit for node 3, and I wanted to enable read only for the node 3. Okay, so endpoint, this is the endpoint 5022. You can use the same endpoint as database mirroring. For example, if you are using database mirroring, the same port number 5022, you can use the same port for HADR. Okay, always on. It's not going to create a problem. When you set up, you can change the encryption data here. Okay, basically it is going to encrypt the data before it sends the records, log records, over the network to the secondary replicas. Backup preference I will explain a little later. For now, let's keep the default prefer secondary. Listener, let me create the listener. We have to add the static IP. I'm going to use okay, that's all we need. Click next, and full backup. Since I don't have the databases on other servers, I can let this wizard take the full backup and restore the databases, the test1, test2 on node 2 and node 3 as well. Whatever the file locations here, I can I prefer to use the same file locations on node 2 and node 3. Okay, that's fine. I have no problem with that. But if I wanted to change the file location to a different location, for example, here the file location for this database is C program files, Microsoft, etc., etc. Okay, but here I wanted to use different different location, C colon some database files folder, something like that. Then I have to manually take the backup, restore it on a different file location where I wanted to on node 2 and node 3. Okay, then set up the join only option. Use the join only option to join the databases on node 2 node 3 to the existing group. Okay, if I wanted to join the databases later, I can use skip initial data synchronization. But in this case, I have the file location exists on all servers. I have no problem using the same location on all servers. Now I'm going to say I'm going to tell the wizard to take backups fresh right now and store in this location, and whatever the backups that I have taken in this location will be used to restore in this in on these servers. Now it's in the process of okay, all right, everything is okay. You might want to take a look at these things, to make sure what it is doing. Basically it is making sure whether the database name that we are trying to add, test1 and test2, exist on node 2 node 3 already. Okay, because we said take a full backup and restore, but if already database is there, then it's a problem, it cannot restore. It is checking to make sure that database name doesn't exist already on node 2 node 3, and just to make sure the disk space is available and compatibility level, etc., etc. You can script it if you want. Okay, so here we have an error. It says cluster could not bring the network resource name online. AG listener, it could not bring online. So now let's see what that error is. We have the availability group created as a cluster resource group under the roles, and this is the service that is running, but for some reason it couldn't create the listener. Okay, so first for now, let's say okay and go here. We have the availability group created, and we have the databases. Okay, I don't know what the problem is, but it said the cluster couldn't bring the resource online. Now let's try to create one more time. Before that, this is the DNS server. Now let's go to the DNS to see if it has created the AG listener computer, not computer, the entry in the DNS. No, it did not create. Okay, so we are fine in the DNS entry. Now let's go to some other location. Here it created the AG listener, so let's delete that. And in the previous video I have been using dev SQL CLU cluster. Okay, let's delete that computer as well, because all right, we don't have this cluster, so let's delete that too. MSDTC, I have been demonstrating this resource group earlier. We don't need that. Let's delete that. Okay, so these four are valid for now. Okay, so if you are creating first time for your demo, for just testing purposes, you should not have an issue. I have been trying several things. What will happen if I do this, what will happen if I do that. So that's why there has been some entries stuck somewhere in the DNS that was not deleted. So now I am cleaning up the stuff. So I hope it should work fine this time. So now I am creating the listener. I am giving the IP address 120 in the subnet 1. Now let's create the listener. Now it created the listener. Okay, it didn't have any problem. Probably because I have been playing with the listener for quite some time. Uh, some of the entries did not delete it properly. Okay, so now I have the listener. This is the client access point. This is the you can connect to the availability group using the listener. Okay, now we can let us check that too. Now we can connect to availability group using the listener. Okay, if I say the server name, I get node 3 because I am directly connected to node 3. Okay, now I will connect using listener. Now server name is node 1. Okay, the server name is the primary. This is the primary. Okay, so if I connect to the listener, it will route the request to the primary database, primary replica. Okay, so let's do one more thing. All right, now let's look into some of the other details of availability group. Here we said primary, node 1 is primary and node 2 is secondary, and these two are in synchronous mode, and automatic failover. And session timeout is 10 seconds. Within 10 seconds the secondary replicas should respond, otherwise secondary replicas will be put in asynchronous mode or sometimes disconnected mode. Okay, so before we do failover, before the manual failover, now in node 1 node 2 are in synchronous mode. If I do a failover manually between node 1 to node 2, then it is called as manual failover because there is no data loss between node 1 and node 2. But if I do a failover manually from node 1 to node 3, whereas node 3 in asynchronous mode, then it will be a forced failover. So there could be some data loss. Okay. I have set up automatic failover between node 1 and node 2. We need to be careful. If you are testing, go to the properties of the availability group. In the failover tab, you need to specify more than 2, because for testing purposes we will be failing over a couple of times, maybe 5 to 10 times between different nodes, node 1, node 2, node 3. Okay, but Windows, it will automatically fail over for maximum number of 2 in 6-hour period. Okay, so if we bring the server down after a couple of times, then cluster will not fail over, because we have said here you do that for 2 times. Okay, so here we have to say 20 times, for example. That means it will fail over automatically 20 times within 6-hour period of time. And if again there is some network glitch or some server goes down after 20 times, then cluster will not fail over. Okay, then that means you really have unstable servers, unstable infrastructure. So you need to appropriately identify the right number for your environment. But for demo purposes, I will be failing over multiple times, 5 to 10 times. I am giving 20 times failover limit for my demo purposes. Okay, now we let's open the dashboard. Okay, so the availability group is hosted by node 1. Now let's bring the host 1 down. Now we have this node 1 down. Let's refresh the dashboard. Okay, now you see that node 1 is down and node 2 is primary, because the cluster failed over the services from node 1 to node 2 and made the node 2 as primary, and node 1 is in disconnected status, not synchronizing state. Okay, the moment we bring this server up, then it will take the secondary server role, secondary replica role. Let me refresh. Okay, since we set up synchronous mode between these two servers, automatically the node 1 took the role as secondary and it is in synchronized status. Okay, so we didn't do force failover. If we do force failover, what we did manually failed over from node 1 to node 2. Okay, so we can again simulate that scenario. We can bring the node 2 down. Okay, so the node 2 is down. Now the services should go to the node 1. Node 1 is primary now, should be primary now. Okay, so the node 1 is primary. Okay, so now node 3 is synchronizing. Since it is in async mode, async data transfer, it will always be in synchronizing or not synchronizing or disconnected state. Okay, so the node 2 is down. What we did, manual failover from node 1 to node 2 and node 2 to sorry, automatic failover from node 1 to node 2 and node 2 to node 1. So let's bring node 2 up. Now let's do a manual failover. Since it is in synchronous commit mode and there is no data loss, that is why you don't see the warning, but whereas you see the warning in node 3 because node 3 is in asynchronous mode. So now let's do a manual failover to node 2. You can see the cluster is changing the owners for the resource group. Now it is in the process of bringing the resources online on node 2. The moment it brings the resources online, you will see the failover is happened here. Okay, so the node 2 is primary. Let's refresh this dashboard. Alright, now let's do a force failover from node 2 to node 3. So there will be data loss because one of the replica is in async mode. You can see here it will try to bring the resource group on node 3. Okay, so now we have everything up and running on node 3. So it is fine here. Let's refresh this dashboard. Now node 1 is primary and node 2 and node 1 are secondary. Since we did a failover to async mode, we did force failover. The secondary replicas database will be put in suspended mode. It will give an opportunity for us to detect if there are any transactions that did not happen on node 3 during the failover. So if you see that, if we think that there are no transactions, then we can resume the data movement. Now let's resume the data movement for the databases on node 1 because let us say we identified that there are no transactions that has been in pending. Otherwise you might have to take a backup and see the difference between the tables. Now let's refresh the dashboard. Okay, so everything is fine because the primary is synchronized and the secondaries are synchronizing. Okay, now again let's fail over back to node 1. Now let's refresh the dashboard. Since we did the failover, the force failover, it has been set as a not synchronizing because that databases are suspended on secondary replicas. Let's talk about the backups. At any time, you can connect to the servers using the server name without any problem. Okay, but if the server fail over from node 1 to node 2, then you don't know exactly which one is primary. Okay, so in the application connection string, you might have to specify the listener name to correctly route your request to the primary replica. Now let's talk about the backups. By default, this is the option that is selected. That means prefer secondary. And there are other options. Prefer secondary means prefer secondary replica for taking backups. So what you can take backups on secondary replica? You can take full backups. Again, copy only full backups. You cannot take a normal full backup. You can take copy only full backup, and you can take log backups. You cannot take differential backups on secondary replica. You can take differential backups on primary replica only. Okay, when you take log backup, then all the replicas will be synchronized. Okay, so all the replicas, the LSNs will be cleaned up, the log file will be wiped out. Okay, so you can take log backup on any server, it will be replicated to all servers. But if there is any data pending, then it will not truncate, it will not set the distributed option for that LSNs. Okay, secondary only means you are going to take backups only on secondary, not on primary. Okay, so it will not fall back on primary at any cost if you select this option. Primary means obviously you want to take backups on primary only. Okay, any replica doesn't matter, whichever it finds first it will get it. Okay, so prefer secondary. Here you have the backup priorities. For example, if you have multiple secondaries, let us say you have two secondaries, and which one you wanted to take backup. Yeah, okay, so here is where you set the priorities for the secondaries. If a secondary, in this case node 2 and node 3 are secondary, okay, both has same priority level, so whichever appears first in the list, it will take that server and it will start taking backups on the node 2. Okay, so if I wanted to specifically take the backup on node 3, then I have to use uh, different higher priority. For example, 51 is higher than 50. Okay, then I can set something like this. So now node 2 and node 3 are my secondary replicas, and out of node 2 and node 3 I have given more priority to node 3. So now node 3 should be taken for taking up the backups. Okay, now let us see, you might be a little confused what this priority is, something you might be a little vague on this concept, but let's work on this. Now let's create a maintenance task. Okay, so let's create the maintenance plan. let us say log backups. I'm not sure why I couldn't drag. It looks like there is some bug in maintenance plan. Okay, so I don't want to waste my time on this. Basically, uh, in the maintenance plan, when you schedule a backup, uh, it the backup that runs on maintenance plan, it has some logic. If the preferred, if the server is preferred, then take the backup. Otherwise, don't take backup. It's not just like straight away taking backups on that server. Okay, it has some built-in logic to check for the preferred server, a preferred replica. Okay, so let's open the properties again. Here, these are backup preferences. It is not enforcing you to take backup on certain server. Okay, you can browse the servers using the DMVs. Okay, is this server preferred replica for backups? Then you take backup, something like that. Okay, for example, you can always straight away go to the server, for example node 1, and take backups. Okay, so let's take backup now. It doesn't stop me from taking the backups straight away on the server. For example, let me take backup of test 1. Okay, so I'm not saying copy only. Okay, so everything else looks good. So let's generate the script for this backup instead of directly taking from GUI. Now I can directly run the backup using script like this. Okay, it doesn't stop me from doing that, but you can say something like this, if it is preferred replica, for example. Okay, you can find out if this replica or if this server is preferred for taking backups, something like this. We have set backups preferred replica is secondary. That is why node 1 right now it is primary. It is returning 0. Okay, uh, if I go to node 2 and run this query, I get 0 because of the priority. I said I have node 2 and node 3 both are secondary, and I wanted to give more preference to, more priority to node 3. Now if I run the query on node 3, now I should get value 1. Okay, so this is the preferred replica for taking backups. Now I can put a condition like this: if this is equal to 1, then take backup, otherwise don't take backup. Okay, I can run this script on every server. I can run this script in the SQL Server agent job, and I can execute the job on 3 servers. So at any point of time, that there can be only one server which can take backups. The rest of the servers, when this condition will fail. Okay, for example, if I say something like this, okay, I think you got the point. Um, I will execute the script on every server. So based on the backup preferences, if I set node 3 as a preferred server, then this script will successfully execute on node 3, and for node and on node 1, node 2, this script will not take backups. Okay, this is how I I prefer to take backups on always on availability group. Okay, but you have to remember one thing. If you, for example, if I run this backup on node 3, it will fail because backup is not supported on secondary replica, because this is not a copy only backup, this is regular backup. Okay, so that is something you have to remember. Now let's take backup of the test1 database, and after that we will take the backup of log. Now this will work fine because I'm directly running the backup script on node 1, and node 1 is primary. That is why this backup is succeeded. Okay, this is my backup. Okay, now I can take backup of a log backup on any server. Okay, now let's take log backup. I can take differential on a primary server. Okay, now let's take log backup. When you take backup on any of the secondary replica, then the log, the LSN will be truncated on all 3 servers. Okay, on all replicas. That you have to remember. You can take log backups on any of the server. Typically, you will want to take backups, full backups and log backups on secondary servers. Okay, that's what we have set in the preferences. Okay, and you can run the reporting queries on some other server. That way you can balance the load. You don't want to run the backup on the live database server where you have high traffic, and simultaneously when you are taking the backup, then it might block the transactions. So you don't want to put a lot of load on one server. You have to distribute it. For example, live transactions on one server, primary server, backups preferred to run on secondary server, and if you have one more secondary server for reporting, then you can run the application, the reporting users, to route to the report server. Okay, so you can say a read-only connection intent for that reporting server replica. Then reporting users can use that additional parameter. And another thing regarding backups is you can take log backup on any of the server. Okay, it doesn't need to be on primary or particular secondary server. You can take log backup on any server, and you have to keep them in one place. For example, you take log backup on node 2 in one place and log backup on node 3 in different place, and if server goes down or you are restoring database from the log backups, then you have to have proper sequence of the log backups. So the best practice is you take log backup on any server, but store the log backup in one common place. That way you have the list of log backups in sequence for you to restore on a different server. Okay, that is regarding the log backups. And now let's create one more availability group just for testing purpose. I said just before I will create another availability group. So we don't have any more database, so let's create one more database. Okay, so we created a database. So now, okay, we need to take the backup before we. Okay, we took the backup. Now we can select the test3. Secondary, we can read the database on secondary replicas. Endpoints 5022 backup listener. We can create a new listener. Okay, so we created another availability group. You can see here two resource groups are created. For every availability group, we have one resource group created here. Okay, so here you can see AG listener, and for this availability group it can be accessed by AG listener 1. Okay, so that is the story behind the scenes in the cluster. Now we can fail over the availability groups to a different nodes. For example, availability group 1, node 1 primary, and availability 2 could be secondary. All right, now we have failed over. Now if for some reason if node 2 goes down, then AG2 will fail back to node 1 because we set it up as automatic failover. Okay, so we can see the dashboard of this availability group. Okay, for this AG2, node 2 is primary. Okay, look, now let us generate some load. Now let's do one more thing. Now let's drop the second availability group. So the AG2 is dropped. Okay, you can see the test 3, it is in restoring mode because of secondary. Alright, all three nodes, the test 3, this is the AG2 availability group 2 database, it's in restoring mode. Okay, so now we have availability group 1. We cannot drop this database because you can say close all connections, and it's going to fail because this is part of availability group, and you cannot drop a database if it is part of availability group. you have to remove this database. You have to remove this database from the availability group, and after that you can drop it. Okay, now let's generate some load. In fact, I have created some scripts. So let me, okay, so now this is on node 1, and this is on node 2. Okay, now let's look into the dashboard again. We have, for the availability group 1, node 1, node 2 are in synchronous commit replicas, and node 3 is asynchronous. Okay, that means when a record is inserted into node 1, it will get inserted into node 2, and both nodes the record will be inserted, and then response will be sent back to the client. Okay, so log will be hardened in both places, so it will take some time. You will see the performance. For example, I don't have the T1 table. Let's create a T1 table. Column 1, column 2. Okay, I created this table on node 1. You will see that on node 2 this table should appear, and similarly on node 3 as well, because when we create the table, it will create on node 1 and node 2 simultaneously. Okay, so then I will get a response saying that table has been created. But on node 3 it will take some time. That is a asynchronous process which will take the DDL changes, that is create table 1, that creates table schema. The DDL will be replicated in asynchronous fashion towards node 3, but on node 2 it will simultaneously, it will be there. Immediately you will see uh, the table. Now let's generate some load on now. I am creating 10,000 rows on node 1. Okay, so let's change the table name, so database name, to table test1. Okay, so now 10,000 rows are being inserted. You can see currently it is processing 7,800 something. Okay, it's done. Okay, 9,999. So it took 27 seconds, you can see here. Okay, now what I will do, I will change the synchronous to asynchronous mode. Okay, so automatic failover, now I cannot do. It will give an error if I say automatic failover. Okay, now all three are in asynchronous mode. You can see it is synchronizing because asynchronous replica cannot be in synchronized status. Now uh, let us add some more columns because we have send queue. Where is that send queue? Okay, here it is. I don't want issues. Redo queue. Okay, send queue is on the source, on the primary. Redo queue is on the target. Okay, now let's generate 10,000 more rows, and let's see how long it's going to take. If I execute this, you can see the log send queue and read queue, redo queue. Okay, the size of the send queue and log queue in kilobytes. Okay, so now everything is done. It looks like there is no data in the queue. That means this is completed. Okay, now you can see the time it completed in 14 seconds. Earlier it took 27 seconds. So 10,000 rows has significant difference. Okay, um, so you have the transactions will take some time, but the only advantage is you have hard standby in the server node 2. That is the only, that is the biggest advantage. So you have to you have to decide whether you wanted a hard standby, that is your important thing, or you wanted your transactions to run faster. I guess most of the people will prefer their transactions to run faster. Okay, so synchronous mode, I don't think anybody will use it. Personally, I have not used synchronous mode, but without synchronous mode you cannot do automatic failover. That is a drawback. So it is something that you have to carefully put your thoughts to see what you are trying to do. You will not have automatic failover if you don't have synchronous replicas, synchronous commit between the two replicas. Okay, but you will see the significant transaction difference here, the time. This is most important than anything else, I would say. Okay, now you can see it has 19,099 rows here. Now let's do one more testing. Okay, so this time what I am going to do, I am going to bring the node 2 down. Okay, so the node 2 is down. Hold on, let me bring the node 1 back. So I will say synchronous failover. Yeah, it could be automatic. So okay, now node 1 node 2 are synchronous and automatic failover, which is possible, and node 3 is always in asynchronous mode. Okay, so now I will bring this server down. Even though the replica node 2 is synchronous, if it is down, then the synchronous will become disconnected status. Okay, so the node 2 is disconnected and node 1 will operate as usual. Okay, the moment node 2 went down, you cannot think that okay, both are in synchronous mode, then a record comes to node 1 has to insert into node 2, so node 2 is not available, so the transactions will not go through. That's not the case. The transaction will still go to the node 1, and it will be inserted into the node 1, and it don't bother about node 2. So when node 2 comes back up online, it will pick up the transactions. The moment it is up to the par with the node 1, then it takes synchronous commit replica role, and it will start synchronizing the data. So now the scenario is node 2 is down. Okay, so node 1, node 2 are in synchronous mode and automatic failover. Node 2 is down. That's the scenario now. Now let's insert some more rows. This is node 2, and let's create one more. Now let's this is node 1, and this is node 2, and this is node 3. Let's generate some data on node 1. Okay, so the node 2 is down. We cannot run any queries. So let's run. We have 20,000 rows. Okay, so let's generate 5 more thousand rows. Now I have generated 5,000 more records on node 1. Let's see on node 3. Okay, let me copy the node 3 script. Okay, node 3, I have 25,000 rows. It has been replicated to node 3. Now let's see. Okay, it says node 2 is down. Okay, so now what we do, let's bring node 3 and node 1 down. Okay, now we have all the nodes. All the nodes are down now. Now let's bring node 2 up. Okay, so the node 2 is up and running. Let us see the status of availability group. It is in resolving status. Yeah, it will be in resolving status. Okay, so now you have to decide what you want to do. If you wanted to run node 2 as a primary, then you have to lose 5,000 rows. Okay, for example, Okay, now we have test3 database. Now let's add the test3 database to the availability group. Okay, so add the test3 database. Since we already have the database on node 2 and node 3, let's skip the data synchronization. Okay, so we added the test3 database. Now the availability database are test3, and this database we didn't join the database to availability group. That's why there is a warning message there. Similarly, it should be the same on node 3 replica. Okay, node 3 replica, we have to resume the data movement. Okay, now what we do is, let's see if there is any records. Okay, there are no tables in that. Let's create one table. Create the table as T2. Okay, so I inserted some transactions into the table T2. Okay, so now let's take backup, log backup. Here we say truncate the transaction log. Okay, so whatever the records that we inserted, it will take backup, log backup. Okay, so it says there is an error. Okay, it says that we need to restore the log backup. Okay, so let's restore that log backup. Keep that in no recovery. Okay, so now we restore the log backup on node 3. Now let's join that. Now you can see that when we add the test3 database to the availability group, and whatever the log backups that we have taken after that, we have to restore all of them on the secondary replica before we join the database. Otherwise it is going to create a problem. It is going to say log backup is required. Okay, because it cannot continue. Okay, that is something you have to take a note of it.